and the one that's just called file folder that does not have a zipper in the middle. Click the one that does not have a zipper in the middle. You're gonna hit training dog cat 1000 without a zipper in the middle. Without a zipper. Hit that. This time we're going to be uploading dogs pictures, so do dogs. If you're uploading cat pictures, do cats. Alright? So we're going to hit dogs. And then there will be a bunch of photos here. So what we're going to do is we're going to click on nothing here. And then we'll drag our mouse cursor down. And then it will start scrolling automatically. Once the scroll bar on the right side of your screen reaches around the third way down the screen, it's going to have around the 300 photos selected. So let's wait here until we reach a third of the way there. Wait. I think I went a bit over. It's alright, it doesn't matter. Then we're going to hit open. Remember, you got to stop clicking, and then we'll hit open. And then we'll load up the images. $451 images, 430 images. That should be good. So once you're done with both steps, type it in chat, please. I need everyone to type it in chat, so you all need to. All right, thank you, Amina. Thank you, Jesse. Thank you, Jeremiah. Thank you, Shadrach. Alicia, ready to go. Good. Thank you, Oscar. Thank you, Walter. Is this the whole class? Because I'm not sure how many of you guys are there. Done. Alright, I'll wait a bit more. Seems like you guys are not all done yet. Thank you, Gibson. We'll be waiting a couple more seconds here. Is everyone done now? Is anyone not done, rather? Can you type that in chat? All right. I think you guys are mostly done. So we'll move on to the next step now. So next, we're gonna, before we hit train model here, we go to advanced. There is a couple of terminologies here that I think we ought to go through. So let's explain those. Epochs, batch size, learning rate are the three terms laid out here. So let's go over them one by one. That epochs, the number of times it will go through every single picture here. So we have 430 and 451 pictures. Total of 980 pictures here. Well, no, 880. I'm stupid. 880 pictures here. At the epoch of 50, we're going to go over them 50 times. So that's around 40,000 or 45,000, 44,000 times. So we're going to go over 44,000 different photos. Or rather, we're going to go through the whole library 50 times. Whole library of 880 photos 50 times. That's what we're doing here. That's what epochs is. Epochs of 50 means. Batch size is the sample size per training. What does sample size mean? So a machine, if it were to go through 880 photos at once, would take forever to process anything. Rather, what we do is chosen. Then train it based on that 16 photos. Is photo 1 a dog or cat? Is photo 2 a dog or cat? Repeat that. And it would find a correlation among that 16 batches, and that'll get stored. And it will take the next 16 batches, calculate from that, and then store it. And then it will compare those batches. That's how it's done. And then it's not stated here, but there's called iteration. Iteration would be the number of training with the current batch to finish one epoch. So we have a batch size of 16. And we have 880 photos. If we divide 880 by 16, we will get 55 as our result. That means we're going to have 55 iterations per epoch. Because we're taking out 16 photos at once, in order to go through one sample size, which is 880 photos, we would iterate through them around 55 times. That's what we're doing. And then we're doing that 55 times of it, 50 times again, because we have 50 epochs. So in conclusion, we would do around, so that's 16 batches. So that's 55 iterations per epoch times 50 epoch. So we'd be doing around 2,750 iterations of this machine learning. We're going to hit train model here. That's what epochs, batch size, and iterations is. Iteration is not here, but it's an important one to know. Epoch, remember how many times we go through. Batch size, how many are we picking out at once from the sample. iteration, how much does it take to go through one sample? Or just one batch, whatever, however you want to see it. We're going to hit train model, preparing data, and it's going to take a while. I should have done that first, actually. So we'll wait for the training to complete. Okay. It's gonna take, depending on your computer, I'm not sure how long. Mine is a pretty fast computer, so it doesn't take that long. But yeah, it might take a little while. I'll wait on, type it in chat when you're all done with this part. You guys don't have to touch anything on the epochs and batch sizes. It's just explanation. I wasn't speaking. I see Amina and Jesse completed. Good job, guys. Yeah, I will wait for everyone else to finish what they're doing here. So we got Oscar done here as well. If you guys are stuck on a step, please ask for help. I would rather have everyone go through this part. Thank you, Jeremiah. I think that means done. I'm not sure what Heko is. Alright, that's around 5 people. I think I'm still missing quite a bit of people, so let's wait a bit more. You guys' window should look something like this one. Thank you, Alicia. Thank you, Walter. I think that's about done from the people I've seen from chat. Okay, I'll move on to the next step. So the machine is now done calculating a model. It has the model for us. It knows now how to distinguish between cats and dogs. We do not know exactly how yet. I'm not exactly going to go over what each individual line of code does here, but rather we're going to first test it out. So input, set this to on, hit webcam, and hit file. Not webcam, because we're not identifying ourselves yet. I'll tell you what this means in a bit. So we can hit choose image from your files or drag and drop here. Click this again. And then navigate to the folder that you guys are using. So the one without the zip, zip in the middle, without the zip in the middle. So data.cat 1000, sample data 1000. And then instead of going to training, we go to test dog cat. Click that. And then there will be a folder inside it called test. Hit test. And then hit whatever you want to hit. Hit dog or hit cat. I'll do cat. And pick a random cat file. There's around 32 of these. Hit one of them. I'm going to hit cat 16. Hit open. It will identify if it's a cat or a dog. Mine says it's a cat. This one, I'm pretty sure that it's a cat, and the machine says so too. You guys can repeat this as many times as you want. Let's this time try it from a dog file. Dog 8. Dog 100%. What this percentage means is how sure your machine is. Most likely, unless you have an exact replica, so the same file that you train with it as an output preview, or even if you trained it with the same file actually, it will almost never get a full 100%. But it will get very close to 100 if the machine is sure. Very, 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 very sure. It will be like 99.99997 or something. It will just print it out as 100. That's what 100 means in this case. Not necessarily that it's 100% absolutely perfectly sure. No, that's not what it is. If you guys can explore around this, but we're going to go a step further in order to implement this a bit more. So we're going to hit export model. And among these, we're going to hit tensorflow.js. This is the one below here is the file. It's a code snippet of my model. I do not know what the majority of your thing does. I really do not know. So we will skip over this. So we're going to hit upload model. What we're doing here right now is we're going to make this into a website / we're going to be able to use it on our phones. So we're going to hit upload model. Uploading. Your cloud model is up to date. Hit copy on the shareable link. And then open a new tab. Then do Control V. It will copy the link. Control V. And then hit enter. It will now give you the machine learn code and the machine, but without all the extra stuff. We don't have to train it anymore. It's already done. So we have just the output here. And then this is the library for this model. So how it compares them. So right now, this model is very complicated. So first, let's we can try what we just tried before. So in webcam, hit. So if you have input on, there was an arrow opening your webcam. So this might work for you. This might not work for you. It does not work for me, even though I have the permissions for webcams enabled here, camera enabled. I do not know why. It doesn't work. So you guys can try file and then choose upload file. And then we'll do dog 30 again, and then we'll likely do the same. Yep. Dog 30 is 100, it's 100% sure it's a dog. What the? Anyways. It's 100%, it was 100% sure it's a dog. The page reloaded. So are you guys following me till here? I'll just get a couple of yeses and then move on. I don't think it was that significant of a step. Just a couple of dones in the Q&A chat, and then we'll move on. So the next thing we're going to do is go over some interesting use cases for this. So yes, this machine was developed this code was developed to identify cats and dogs, but we can use it for a completely different purpose that's pretty fun. So before we move on, you guys can copy the link to your phone. It is possible. So just type the link identically to match your code, or you guys can alternatively, let me give you guys a link here. You guys can manually copy it down, or you can use so websites like shorturl.at. These websites allow you to shorten a URL. So if you copy the link from the top, so let me open this page first. If you copy the link from the top, hit Control C to copy, and Control V here, and shorten URL, it will give you something like this. And then it will be a lot easier to type on your phone to get to that website that you just created. So if you hit this link on your phone, it will eventually lead you to the site that you just created. You'll be led back here. And then try try turning on the webcam, or try selecting webcam, allowing permission and making it work. I was not able to get this working myself. Let me try it again right now. So copy the shortened URL. I'll send this to myself. All right. Yeah, mine here does not allow. So if you see here, mine does not have, even though I have camera just enabled, doesn't do anything, sadly. Unfortunately. If you have an Android phone, there's rumors that it might work. So if it works, great. If it doesn't, well, too bad. One thing that we could do is, if you can't do it with your own face, we can use it to identify. So there's this saying, or there's this way to categorize people. If that person looks more like a dog or more like a cat. So what teacher Lee sent us on the Q&A chat is an example of that use. So the machine is not sure if she's a cat or a dog because she is not a cat or a dog. But looking at her face, it decides what more does it look like. Does she look more like a cat or does she look more like a dog? On the second picture that she sent us, it says a 56% chance that she's a cat and a 44% chance that she's a dog. So we could say that she looks more like a cat. Her face looks more like a cat than she does look like a dog. So try this, and if you can't get it to work on your phone, you can also just find a random picture of a person. So I don't know, celebrities like, who's a celebrity? Yeah, there we go. We got a picture here. I think this was from your class photos. I don't know. Celebrity. Who's popular? I'd rather pick someone that's not controversial. Let's go with I don't know. Taylor Swift here. I really can't think of anyone. So find a random picture of her that's relatively not weird. There we go. I'll hit download, save image as, and then hit save. Go back to our teachable machine. Choose upload. And then go to the downloads folder. And then find your picture. Open. Says she's 100% dog. That's interesting. It usually never gives you 100% for a human, but apparently she looks so much like a dog. I am not sure what this is implying, but she's a dog. Her face looks like a dog a lot more than she does like a cat. At least in that photo, according to our model. So yeah, the pictures are being uploaded here on the chat currently. Oh, we got 100% dog again. Interesting. Jeremiah is Jeremiah is 100% a dog person. Hey. All right, explore around with this a little bit more. You guys can also do like cat pictures, or you guys can do random animals. So let's say I'm gonna do chipmunks. Monks. Let's download a random photo of a chipmunk here. Let's say this one. Hit save image as. Hit save. Go to teachable machine. Choose from uploads and files. Might work. Open. Apparently the squirrel looks 100% like a cat. Do you guys think it looks more like a cat or a dog? That's up for you guys to decide. I personally do think it looks more like a cat than a dog. 100% though. See, this is why machine learning is inaccurate at times and you need to be careful with how you use it. Obviously not a cat, but it says 100% a cat. Not always perfect, as we see here. So explore around with this a little bit, and then after this, I'll hand it over to our next presenter. You guys can play around with this for a bit while we transfer this teaching session to our next teacher. I think it's gonna be Ian. All right. Thank you, guys. I'll maybe come back today. Maybe tomorrow. We'll see.
Okay. So while you guys are having a little bit of fun with that, let me just prepare what I'm going to teach today. So I'll start around like 42-ish. Um yeah. Okay. So let me just share my screen and we'll get started. Oh, window. Okay. Uh, okay. So the next thing we're gonna talk about is um supervised learning. So what that's gonna be is this is a part of machine learning where like if you know what the word supervised means, it's basically you're watching over the program as the program basically learns. So in this case there is always going to be a cause and there's always going to be an effect. And in machine learning, we have specific terminologies for that. So the cause is going to be known as the independent variable, where that's going to be like affecting what is going to be the output, and the output is going to be called the dependent variable. So the dependent variable is going to depend on what the independent variable is, basically. So, what we're gonna be slightly coding out is this kind of model that is going to predict lemonade sales. So, what we basically talked about just now of the whole machine learning thing, we are going to actually be putting that into code in this case. So we're going to be combining basically the concepts we've learned previously to what we just learned about machine learning. So this is like the data we have for our like mini project. I would put it, but we're gonna do something called lemonade sales. And basically, how this is gonna work is there's gonna be certain dates and you're going to be selling lemonades on those certain dates, and depending on the temperature, which is going to be the cause or your independent variable, then your sale of how many lemonades you're going to be selling will also change. So in this case, in this model at least, the relationship between the cause and then the effect is multiplied by 2. So the temperature is 30, 24, 20, and 40. But everything else, if you look at the sales, it's pretty much doubled. So 30 times 2 equals 60, 24 times 2 is 48, so on and so forth. And given that, let's say you're on like July or June like 17th, and you're trying to prepare for the next day to sell the lemonades, then you see the weather forecast and then it says, oh, it's going to be 40 degrees tomorrow. Then this program will basically predict how many like cups of lemonade you will need to prepare in order to have like basically the right amount. So this is based on like a certain data that you have. um yeah, so this is just completely made up, not saying it's true of any sort, but yeah, so like I just explained, this is the independent variable and this is going to be a dependent variable. And the step we will be doing is um we'll prepare this data and then we'll put it into the model so that it can train itself. And we're by supervised learning, we will be supervising literally as um, it basically learns the data here, and then after training, the AI model will come up with a model, and then that's if we did everything correctly, then it's going to predict that the relationship between temperature and sales will be doubled. So that's what it should be able to predict. Yeah, so this is just another example of what I just talked about. But if the temperature is 15 degrees and then if you have the model and then you input 15 degrees, then the model will predict that you will need 30 cups of lemonade for a day that is 15 degrees. Okay, so that will be kind of like our step by step like timeline of how we will be coding this out. Okay. So, there's two types of supervised learning. So, one is called regression and one is classification. What we just did with the cat or dog, that is known as classification because we are basically seeing whether if given like these two types of data, so we just put in cats for one and then dogs for another, and the AI model was able to classify whether certain photo or whether you looked more like a cat or a dog. But in this case, for lemonade, we are going to be dealing with regression. So regression is more of, I guess, statistic based. So you have more of like a data that is based on numbers, and then you'll be using those numbers to build your model. So yeah, let's get started. So limited sales regression, and let's get started on the coding process. Okay, so what I'm about to show you is very, very important. So what we will be talking about today and tomorrow basically builds up on this concept. So this is very important for you to know. So make sure you remember this. Okay, so let me just zoom in a little bit. Okay, so first we have a set data. So usually like data scientists, they usually like do like a survey, or like if you guys know what a census is, then they basically use that and then to predict certain things about like the society as a whole. So when we have like the given data, that will be our first step. So step number one will be to prepare the data. Okay. And then afterwards, we will create a model based on the data. So before we covered a little bit of Panda, and we will be using those things, that concept to create our model. And Panda, the way they do it, it's actually really nice the way they put everything. So that will be a very helpful tool. And we're gonna create the model, and then step number three is we're gonna use the model we prepared, and then we're gonna train the model. So what I mean by that is there's like this acronym of fit. Basically, the model, the more we train it, the more accurate it becomes. So we briefly covered the term of epochs earlier. So the epoch is basically how many times you're gonna run a certain data. So given you have this data and we feed this into our machine or our computer, then it's going to analyze this data over and over and over and over again. So it becomes basically errorless, or like as accurate as it wants to be. So it predicts the correct data. So that's our third step. And then last, we have to obviously, after we created the model and we trained the model, then we have to obviously use it, since that was our whole purpose of doing this problem, right? So by using the model, we will be basically giving the program a random number, and which is like the temperature of so not like obviously like an unreasonable number, but we will be giving it a reasonable number, and it should be able to predict how many cups we need. So that is our step. Um, Make sure you know this, because everything, again, we do today and tomorrow will build up on this. So very important. Okay. And okay, so first thing is we uh, are going to be using a slightly newer thing today. So we'll be using something called Google Collaboratory. Google Collab for short. So I'm gonna post the link to this in the Q&A channel. So if you guys are able to, and please click on this link. And let me just explain what Google Collaboratory is. So collab for short, so Google Collab is basically made by Google. And the collab allows anybody to basically write and execute Python codes through a browser. So you don't need to download like a separate like ID or anything, but it's very handy because you can use it on like your Chrome or like any other browser you use. And this is pretty much specialized to machine learning or like analyzing data. And with Collab, you can import like a lot of different like data sets, like image data sets, and you can train the model like so it recognizes certain images, or in this case, since we are using the regressive supervised learning method, we can import datas that we have, and that way the Google Collaboratory will help us evaluate the models. And this becomes very simple as it all just boils down to a few lines of code. And Collab Notebook, so Google Collab uses the Google server to basically execute the codes we need. So we are kind of getting the help from Google in this case. So if you guys clicked on the notebook, since it is made by Google, it should connect to your like Google account. And here, there's going to be a blue button that says plus sign and a new notebook. You want to click the new notebook here. So that and then that should automatically go save into your Google Drive. But from the link I sent you, press the plus new notebook, and it should bring you to something like this. And if everyone is good till then so far, then can you guys please give me a thumbs up, or not a thumbs up, but like something that says like done or something like that in the Q&A chat. All right, perfect. Good, good, good. Okay. I'll just wait for a couple of more people and we will be ready to go. Okay. All right. Okay, so I'll get started in a short minute. So, the first thing is, how do you use Google Colab? So, it's pretty different from the other IDEs in that, each like basically section of the code is split off into like these little blocks. So, if you want to like add another like chunk of code, then you have to like press the plus code button. That way, it creates like these different blocks you can use. So just keep that in mind. And if you're not familiar with anything, please put your questions in the Q&A chat so I can try to answer them as much as possible. Okay, so first, I usually like to rename these. So I already have a file that's called Lemonade. So you guys can name it Lemonade, but since I already do have a file, I'll just call it Lemonade like one or something like that. Okay. So I'll give you guys a quick minute to do that, and um, afterwards I'll be laying out the steps in using the comments to explain what we're gonna do. Okay. So first, what we're gonna do is we're gonna import the different modules we need. Okay. That will be our first step. And then afterwards, the other steps we will do is basically the four steps that we covered. So, first step is to prepare data. And then, sorry, give me a second. Okay. And the second step is to create the model. Okay. So, you're going to do create a model. Oh, two, sorry. And after step number three, is going to be train the model. So train the model, and then so that it fits. I'll put that. And then the last one is to use your model. So use the model. Okay. And after that, um, let's get started. Okay, so the first step we need to do is import all the different modules we need. So the modules we'll be using is something called TensorFlow, Pandas, and I'll be importing math just as like a precaution. So it doesn't really cause me like the trouble in case I need to perform any math. Okay, so in here, I'm gonna say first import, and then I'm gonna import the TensorFlow module and as TF since I want everything to be concise, and import also pandas as PD, and I also just import math. Okay. Okay, so those are the three modules we need so far. And after, we're gonna prepare the data. So the data we have currently is just like a link that we have. So I'll post that in also the Q&A channel. And you guys can just copy and paste the link into like the respective parts. So that will be our data that we'll be using. And notice that it says lemonade.csv. So in case you're curious about what CSV stands for, so if I were to click on this data and look at it, it's basically separated by like commas. So CSV is basically standing for comma separated variables. So it's literally variables that are separated by commas. So like 20 comma 40, 21 comma 42, and temperature comma sales. And then this temperature is representing all of this here. Oh, sorry, this row over here. And then the sales are representing the other row. So that's just what CSV stands for. So to start preparing our data, I'll first need to define a variable that is equal to data. So I'll say data and then equals, and now make sure you guys put this in a string. Um, and that will be our data. And afterwards, I will say, um, I'll call a new variable that's called lemonade. And pandas module will help us put this data in like a nice little table. So I'll tell you what that will look like in a minute, but just try to follow this code. So here, I hope that's better. But since we imported pandas as PD, I'm gonna say PD, and inside the pandas module, there's something called read underscore CSV. So since this is a CSV file, this pandas module is obviously gonna read the CSV file. So read CSV, and then read what? We're gonna read the data. Okay. And afterwards, we're gonna do lemonade, and there's a certain function that pandas also has called dot head. But so oh, one more thing. So collab notebook always has it, so you have to run each different like code like block over here. So if I were to just run this, like if I were to run that right now, then it would give me an error since I didn't run the previous block. Yeah, so it gives me an error. So if I didn't run that part, it doesn't know what PD means, and it doesn't know like the like operators that are inside the pandas module. So um in Colab Notebook, make sure you're running each like code block before you go. So it usually takes longer when you first run it, but afterwards it becomes slightly faster. So if I were to run that, yeah, so pandas puts it in like a nice little table, and then inside the pandas there's something called dot head. And then what that does is it gives you like the first five like data sets. But if we, as we saw in the data earlier, we don't really have a lot of data, so we don't really need the head in this case right now. So if I were to run it, then it gives us all our data. But we're gonna be doing another data that has like a lot of variables, like a lot of data. So in that case, the head operator will come in very handy. Okay, so first, this is us preparing our data, and remember how I mentioned the independent and dependent variables? So we first need to actually define those. So under here, I'll actually create like a step one dash one kind of thing, and I'm gonna say define the independent and dependent. Oh, sorry, dependent variables. Okay, and in that we will first say independent equals blank, and a dependent will equal blank. Okay. And so like I mentioned, if we look at this table, the temperature is going to be the independent variable, so what's affecting the sales. And the dependent variable will be sales, basically what is affected by temperature, or the independent variable. So in that case, since we put everything under the variable lemonade, we'll say lemonade, and then this is us using TensorFlow, but the correct syntax for putting that is double square brackets, and we need to do a single quote, and then we put temperature. So that way we're getting this temperature from this data we give, and after we do the same thing for here, double brackets, and this is sales. Okay, so that's the independent and dependent variables. And afterwards, we have to print them. So that's our final step of preparing the data. Okay, so I'm just going to say print, and then independent. And then um, in TensorFlow, there is something called the dot shape operator. So what that does is it's literally going to shape what our data like structure is going to look like. So if I were to put shape, and then you're going to put comma, and then do the same thing for the dependent variable. So dependent. Also, you're make sure you guys are typing all of these correctly. So like make sure there are no typos, because it will kind of yell at you if you don't. But so if you run that, so it gives you 6 1 and then 6 1. So what that means is, take a look at this first row, and that will be the independent dot shape, and then the output of the dependent will be the 6 1 also. So what that means is, six is basically the number of rows, so it's going to be 1 2 3 4 5 6, and then the second one, so the one will be the number of columns, so there's only one column here. So that will be the temperature, and since that's the same for sales, we just leave that as 6 comma 1. And later projects we work on, this will be a lot more complex, but for now it's nice and simple. So up to here, that will be our preparing data stage. So does anybody have any questions, or do they still need to catch up on like typing the code? You can just say like no or something like that if you don't need anything. But after that, okay, I think, yeah. So I think everyone's good. Okay, so afterwards, so after step one, we have to create the model. Okay, so that will, after creating the model, that will lead us to training the model. So in this case, we're gonna use the x and y to keep it simple, x and y variables. But make sure you guys pay attention here, since there's going to be a lot of new operators that we'll be using. So x, and then we're going to be using the TensorFlow. So it's a TF, and there's something called keras. So just like that, and then dot layers, and then dot input, and then shape, and then like that. Okay, so um Keras, basically what that does is it basically allows us to create sort of like a prototype or like a model of something. And if we're gonna get more into something called deep learning later, but it also helps create deep learning models. And The function of this is to basically create comprehensible and like also like sort of like a structured like data, I guess, or like a model of the data. And that allows for the coders to receive the like it basically communicates with the coders in a very effective way. So they can understand the data as well. So all you need to get from this is basically we set X as the independent in this case, and we'll do the same for Y. So Y is TF cares and then dot layers. But in this case, instead of using input, so basically the input as just like the standard input we used in the code quest problems yesterday. Um Basically we're getting the input. So in this case, the input we're putting in is temperature and then the output is sales. So input it's basically taking the temperature and then you might think that we use output, but actually we use something called dense. I'm not too sure why they call it dense, but they call it dense, and then we're gonna put one, and then it's x. So basically, what this is saying is the y variable will be affected by the x variable. Um, and yeah, so that's like the TensorFlow operators. And after we need to create a model, right? So next like variable I will use is model. The model equals, and then we're gonna use TensorFlow and Keras again to help us create our model. So tf.keras dot, and then after in Keras or within TensorFlow and within Keras, there's also something that's literally called models. So as the name obviously says, it is going to model our data for us. So it's going to be models dot, and then inside models, there's something called model, and we're going to model what? We're going to model the x and y. So our independent and dependent variables. So that's going to help us model it. And we have everything prepared in that. What I mean by that is we have everything stored into our nice little variable, so x, y, and then we have model. And then basically x we're reading the first line, and then y we're reading the second line or second column. And model we basically stored all of that into model, and then we told TensorFlow that, oh, please help us create a model for x and y. But TensorFlow now needs like a specific way that we want them to calculate our data. So we're gonna say next we're gonna basically give them like a mathematical guideline of how they want us to solve it. Okay, so it's model dot compile. So it's gonna compile everything. And in case we have like an error, so obviously statistics is very percentage wise. So of what percent success rate will this like data represent basically. So um the basically there's many ways to calculate like the error rate, but in this case we're going to be using something called MSE, which is the like shortened version of mean squared error. So I'll name the like the error rate loss since we are basically losing our accuracy, and we'll name it MSE, which means mean squared error. So if you want to look it up, so mean squared error, it is this long formula of, yeah, so yeah, it's something like that. But you don't really need to know what each of these like things do. Like I'm not too sure as well. But this MSE function will help us calculate the like percentage error kind of. And like if you look at this, it's an estimator that measures the average of the squares of the errors. So it's basically like shortened way that's gonna help us average out our errors that we face. Okay. So that's all for creating a model. Make sure you guys run this. Um, And if there's no errors and you have like the check mark on the side, then you're good to go. Okay. And now we got to watch. So this is where supervised learning comes in officially. So we got to watch the machine or our computer try to learn this data. Okay. So um the um, so we're gonna say model.fit. So the model.fit will basically start generating our computer, and that will basically start the learning process. So that's like the executionary command of the computer to start learning the model that we created. So um, use this model over here, and then by saying model.fit, you're telling the computer start learning this data. And obviously, if you just say this, the computer's gonna go like, what do you want me to like learn? So you specifically need to define what the computer needs to learn. So it needs to learn the independent variable, like that we talked about, and we also need it also needs to learn the dependent variable. And after the concept of epochs comes back in, and that's basically up to us to decide how many times we want this computer to run this program. So just for accuracy, since I don't think it'll take too long, but I'll say 10,000 times since the data is pretty short, and I think 100,000 times is too much right now. So since we're kind of on a time crunch, so I think a 10,000 is a good number. It shouldn't take too long. And you could stop here and then you could let it run. However, just to make this look clean, there is something called the verbose. So if I were to type that out, verbose function, and that's gonna basically gonna tell the computer to just learn on your own. So if I were to run this, then it would basically state every single test case that it goes not test case, sorry, every single like data it goes through to learn. So we would basically get like 10,000 like outputs basically of its learning process. However, we really don't want to see that. In most cases we really want to see the results of it. So if we were to set the verbose as 0, so verbose equals 0, that's gonna say, oh, start like computer, like learn on your own. That's basically what's gonna say. Okay. And afterwards, after actually do want like the last like couple of its test trials to print. So we get to see how accurate it is by looking at like the loss rate. So, basically, we basically type the same thing. So model.fit and then independent and then comma dependent. And then, um, so basically the verbose 0 is gonna stop printing everything. But if we say, epochs and then 10 equals 10, then we're basically telling them you can learn on your own, but I still want to see the last 10 like test trials that you did. So that's basically what you're telling the computer. And if we were to run this, then nothing much would happen so far. So notice this like arrow here, it's still on running the 10,000 here, but once it gets to the last 10, then it will switch over to here, and we will be able to see our last 10 cases. So I don't think it should take too long other than like a couple of seconds. You guys can try running it as well. Oh yeah, so it's already done. So it took like 25 seconds ish. So yeah, let me know if you guys want to. Okay. And you guys try running this as well. I would recommend, but I'm going to actually run this again since it didn't take too long. So notice the loss rate. It got represented in scientific notation, and this is basically saying this number times 10 to the negative fourth power. So that's gonna be like 1, 2, 3, 4. So we're gonna have three zeros in front of this four. So the loss rate, I guess, is 0.0004896, and it's pretty similar. And if we run this again, then it will like lessen the loss rate. So let's try running this again. Then let's see what happens to our data. So let's wait for a couple of seconds. And again, while this is running, if you guys have any questions about what we did previously, guys can leave it in the Q&A channel. And if you guys have any like questions or you guys are getting errors of any sort, then please let me know. Okay, while we wait for this to load. Um, okay, yeah. So if it finished running, so yeah. So notice that we had a 4 here, but by running it another 10,000 times, it significantly shrunk the loss rate to 1. And if we probably run it again, then it will probably shrink more. But I would say like the 0.00013 like 9-ish. It's pretty accurate. It's not too off. So I think it's a pretty good model. I think the computer has a pretty good idea of what our model is going to be. After we've trained it, now finally we are going to use it. So basically we need the code to start like this like the final print statement if you were to like looking at it at like a competition problem or something like that. Okay, so the final like training has ended, and afterwards we basically just need to like print everything out in a sense. Okay, so the way we're gonna do that is we're gonna first say um temperature. So that was our independent variable. I'm going to create a new variable called temperature. And I'm going to use the input. But remember, the temperature can always has to be an integer. So just as a precaution, I'm going to say int. And I'm going to say input. And then I'm going to tell it to say, oh, input tomorrow's temperature. Okay. And then I'll do that. And then that's if we run it, then that's what this guy this like this part will be printed, and then we get to type what tomorrow's temperature is. So that's our first step. And then after I'll create another variable called cups, so like as in cups of lemonade. So that will be our like affected um variable. And since we are dealing with float numbers, I'll say float, and then inside one of these what is it called modules, there's something called the predict, which is obviously going to predict our like so based on the temperature it's given, it's going to predict the number of cups we need. So the way we say that is model.predict. So I'm pretty sure this is in TensorFlow, by the way, but model.predict, and then the same syntax we did up here. So like over here, um, we're gonna say predict, and then we're gonna open up parentheses, and then two square brackets, and then we're gonna say temperature since that was our variable from earlier. And let me check if all our parentheses are correct. Yeah, so I think it should be correct. And after, since we were dealing with float numbers, which is always a possibility, we want to round the number of cups we need. So, basically we just use a round function. So cups dot round, or so cups equals round, sorry. Cups equals round, and then we're gonna round the number of cups like that. Okay. And then the very next last step is to print everything. So, just to review what happened, we're inputting or we're this is what's like our like slot to input the temperature. So it somewhat like feels like a program, and we're actually like using a program. And then afterwards, we commanded cups to equal to the prediction of what it is based on the temperature given. And since we might be dealing with float numbers, then we're just gonna round the number of cups to make it a whole number basically. And then lastly, we just need to print everything. So print and let's try to like make this feel like a program. So what can I write? Okay, I'll say prepare curly brace. I'll explain what that means in a second. Prepare blank um cups of lemonade tomorrow, something like that. And let's also do that. And what we can do, so there's other ways to do it. So you can basically, one way of doing this is you can split it off into strings and you can concatenate the strings. So you can say print prepare plus and then cups plus the other part of the string. But the more efficient way of doing this is using curly brace here and then using the dot format. So I think it was me who covered this briefly yesterday during the code quest problems, but it was the format and then cups. So the cups will basically be replaced instead of this. And let's try running. I don't think I made any mistakes, but let's try running it, see if it compiles. Okay, so it's asking to input tomorrow's temperature. I'll say like 20, like 3 degrees, let's say. And I press enter, then prepare 46 cups of lemonade tomorrow. And if we look back at our slides, um, that was our data. So temperature times 2 equals sales. And no matter how many times I run this, like let's say the temperature is like 45, then prepare 90 cups of lemonade tomorrow. Let's try a couple more. Let's say temperature is gonna be like 11, then prepare 22 cups of lemonade tomorrow. So this model is pretty accurate. And if we probably run it more times, I don't think it'll affect like the final like outputs as much since it's pretty accurate already. But if you want to improve the accuracy, then you just need to keep on running this. Or another way we can do it is add more epochs. So add like one or two more zeros, and that will take a lot longer time, but it will be a lot more accurate. So your loss will decrease the more you run. And yeah, so and then depending on what temperature you put, that will affect the number of cups of lemonade that you need to sell. So that was like our little program that we did. Um, yeah, so oh yeah, so over here, let me find that part. Uh, x equals oh yeah, over here. So um I forgot to explain this here, but where the one came from was so like I said, x was the independent variable, and this is the independent variable, and then y is a dependent variable, and this part's the dependent variable, and then the ones basically came from this other half of so one, and then the one came here, and then the other one went over here. So yeah, that's kind of like the format that we want it to be in. Again, we're gonna do something very similar to this tomorrow as well, except it will be a lot more complicated, and the data will be a lot more longer than just the simple like 6 pieces of data. So yeah, be prepared for that. I hope this was a pretty like interesting experience, and I hope it was something new. I know you guys have been like solving a lot of just like competition problems or like the theory problems, things like that. But I hope this was a little bit interesting, hopefully. Seeing how we code out like machines and help it learn so that it creates like pretty accurate data. But yeah, again, any questions, please leave it in the chat. but otherwise, I'll pass it on to our next speaker to share what they have for today.
Okay. So, um, pretty soon we're going to be having a sort of like a sort of test. Um, and for the test, there's going to be a theory portion and a programming portion. Um, so for the theory, and this is going to be around like the 25th. Um, And yeah, so the theory portion is essentially going to be made up of um, 40 different questions along the lines of the multiple choice practice homework that we gave you over like the past week or two. Um, of course, they're not going to be the exact same problems, but they are going to be very similar. They're going to be of a similar style. Um, and yeah, it's just 40 questions that are very close to the multiple choice practice. For the programming section, there's going to be 10 questions. The level is going to be around similar to the coding bat and code quest that we went over. So yeah, 10 questions, and they're going to be released, like I said, on the 25th, 10:30 a.m. Your time, and then the due date is going to be on the 26th, 10:30 your time. Um, yeah, there's you're not going to be allowed to ask questions about the problems, or you're also not able to like collaborate with other people to try and solve them. However, if you are having trouble with the Google form or the website that we're using to administer programming test, then you are able to ask us questions about that. And before we go, I'm going to show you guys how to create an account on HackerRank, which is where we're going to be doing the test. So I'll send the link for this into, I guess, the Q&A section. So go to that website and you'll go to this kind of page. And to sign up, there's two big sign up buttons here. You can press either one to do that, to create an account. And you'll go to this page, just press I'm here to practice and prepare, and then press create account. I am logged into my own account. That's not what we want. Sorry, one second. And then you're going to come to a page like this, where you just fill in your first and last name, your email, and the password that you want to use for this for the account, for your HackerRank account. And make sure that you agree to HackerRank's terms of service before you create an account, or else I don't think it lets you. And one second, I'll show you guys what the UI kind of looks like, and then I'll show you how to like create some code and run them so that you guys know how it works. Right, give me 1 second. Okay. So, let me share my screen again. So yeah, this is going to be kind of what our problem looks like. So, or like one of the problems, like some of the problems are going to look like. you're going to see a little bar here which says problems, submissions, leaderboards, discussions. Um, Most of these you're not really going to need. The real place that you're going to need to know is problem. Um, and it'll give you a sort of, like in CodeQuest, it'll give you like a problem background, it'll give you your input format, it'll give you your constraints, it'll give you your output format. And it'll give you like some samples, inputs, and outputs to make sure that it's going correctly. Here is where you're going to be writing your code. So, like, yeah, this is just where you write your code. Um, and yeah, you can like just put like a print statement here. Um, but yeah, so to run your code, you're going to want to press the button run code here. Make sure you don't press submit code. I think it gives a pop-up before you submit it again, but just make sure that you don't accidentally press this button, or else you might accidentally submit code that you don't want to, and then it'll give you a bad score. So yeah, press run code, and then it'll wait a second, and then this kind of thing will show up. It'll say test case 0. Sometimes I don't know if it's for this for the there, but like there are multiple test cases sometimes, and it'll say your code did not pass this test case or it did, and your output is supposed to match the expected output. So for every single test case, of course, hello is not what like our expected output, so it says that it doesn't pass the case, but um, yeah. Basically, just put your code in here and then run code, make sure it goes here. And then if everything goes well and you think you're ready to submit, press submit code, and then you can submit it. And to make sure that you've submitted it, you can go to submissions and it'll show that you put a submission for this problem. Yeah. I think, oh yeah. You can also, because there's, they give you, when you press run code, they give you a very specific input. If you want to test your own inputs, you can write them in here. And then you can give like a separate input. And then to get like, it won't tell you an expected output because it doesn't know what the expected output will be. So you have to like do the actual thing yourself and then make sure that your code is giving the correct output. But you are able to put in custom inputs using this check mark and just putting it in here. And yeah, I think that will be everything. That's just an explanation of the test that's going to come in 2 days, I believe now. Maybe it's 1 day. I'm not entirely sure. But yeah. If nobody has any more questions about the test or anything that we went over today, then you guys will be free to leave.